Good morning, all of you. Are you ready for learning? Yeah. Today, we learn about force between two parallel wires carrying currents in the same direction. Here, two infinite long current carrying wires AB and CD, I1 and I2 ampere of current is flowing respectively, both of them. Okay, both wires are separated to each other at distance r. Okay, all of you know that current carrying wire produces magnetic fields. Okay, here two currents are flowing in two different wires, I1 in AB, I2 in CD. If the magnetic field produced by current I1 at any point on CD is V1, we assume, then from the expression of magnetic field, B1 is equal to mu naught I1 upon 2 pi r. Okay, this is the expression of magnetic field produced by a current carrying thin wire or conductor. Okay, this magnetic field B1 produces force F2 and magnetic field is perpendicular to the wire CD. Okay, then exerted force F2 is equal to I2 B1 L sin theta. Here magnetic field is perpendicular to the wire CD, therefore here theta is equal to 90 degree. Okay, because magnetic field is perpendicular to the wire CD. Okay, therefore F2 is equal to I2 B1 L sin 90 degree. What is the value of sin 90 degree? 1. Okay, that implies F2 is equal to I2 into B1 mu naught I1 upon 2 pi r. This is the value of magnetic field produced by current I1 on CD, that is B1 into L into 1. Okay, after simplifying it, F2 is equal to mu naught I1 into I2 into L upon 2 pi r. Okay, this is the expression of force exerted by the magnetic field B1 that is F2 is equal to mu naught I1 I2 into L upon 2 pi r. Okay. Similarly, we can find the magnitude of F1 like the magnetic field produced by the current I2 on wire AB is B2. AB is B2. Okay. Here B2 is the magnetic field produced by the current I2 on wire AB, and this magnetic field is perpendicular to the wire AB and exerted force F1. Okay, that implies B2 is equal to mu naught I2 upon 2 pi r. This is the equation 2. If F1 be the force exerted by this magnetic field, okay, then F1 is equal to I1 B2L sin theta. Here magnetic field B2 is also perpendicular to the wire AB. Okay, that means angle between them is 90 degree. Okay, here theta is equal to 90 degree. That implies F1 is equal to I1 B2L sin 90 degree. That implies F1 is equal to I1. We put the value of B2, that is mu naught I2 upon 2 pi r L into 1. The value of sin 90 degree is 1. That implies F1 is equal to mu naught I1 I2 into L upon 2 pi r. This is the force, this is the expression of force exerted by current I2 on wire AB. Okay, when we compare both forces F1 and F2, we find that the magnitude of F1 and F2 are equal to each other. Okay, here wire is infinitely long. We assume a condition such that a small f is the force per unit length of the wire. Per unit length of the wire. Then if F be the force exerted per unit length of the wire. Okay, if a small f be the force exerted per unit length of the wire, then F is equal to F1 upon L or F2 upon L, because both F1 and F2 have same magnitude. Okay, therefore F is equal to mu naught I1 I2 into L upon 2 pi R into L. This L cancelled to this L, therefore F is equal to mu naught I1 I2 upon 2 pi R. What will be happen? F is equal to mu naught I1 I2, a small f is equal to mu naught I1 I2 upon 2 pi R. This is the expression of force acting per unit length of the wire. Okay, on the basis of this force we can obtain the mathematical formula of SI unit of current. Can you tell me what is the SI unit of current? Yeah, ampere. Okay, definition of 1 ampere of current. Definition of 1 ampere of current. Okay, definition of 1 ampere of current. Here we assume that if I1 is equal to 1 ampere, I2 is equal to 1 ampere, R is equal to 1 meter. Okay, the length, the current flowing in wire AB is 1 ampere, CD is 1 ampere, and the distance between both wire is 1 meter. Then F is equal to mu naught into 1 upon 2 pi into 1, because F is equal to mu naught I1 I2 upon 2 pi R. Okay, I1 is equal to 1 ampere, I2 is equal to 1 ampere, R is equal to 1 meter. This shows that F is equal to mu naught upon 2 pi. This shows that F is equal to mu naught upon 2 pi. Okay, the numerical value of mu naught upon 2 pi, it can be also written as 2 into mu naught upon 4 pi. That implies F is equal to 2 into 10 to the power minus 7 Newton, because the numerical value of mu naught upon 4 pi is 10 to the power minus 7. This shows that 1 ampere is that amount of current which is flowing through infinite long current carrying conductor and exerted a force of 2 into 10 to the power minus 7 Newton per unit length of the wire when both wires are placed at a distance of 1 meter. Okay, again we repeat, 1 ampere is that amount of current which produces force of 2 into 10 to the power 7 Newton per unit length of the conductor when both wires are placed at a distance of 1 meter. This is the mathematical definition of SI unit of current. Okay, it is very important term for your board examination. Okay, here special cases are also presented. If the current is flowing in the same direction, then when we apply the Fleming's left hand rule, then we find that the nature of the force is attractive. Nature of the force, nature of the acting force. Okay, acting force, a small f, that means mu naught I1 I2 upon 2 pi r is the magnitude of the force acting per unit length of the conductor. And what is the nature of this acting force? Nature, that means forces are either attractive or repulsive. When we apply Fleming's left hand rule, then we found that if the currents are flowing in the same direction, then the nature of acting forces are attractive. Okay. Similarly, second case are also arised if the I1 is flowing in upward direction and I2 is flowing in downward direction. Here two parallel current carrying conductor and I1 is flowing upward direction, I2 is flowing in downward direction. Then the forces are acting between them have repulsive nature. That means if currents are flowing in opposite direction, then forces are repulsive, repulsive. Okay. What is the nature of the force when current are flowing in opposite direction? Repulsive. Okay. Now I explain Fleming left hand rule. Stretch your 3 fingers of left hand, central finger, forefinger and thumb. If central finger points the direction of flowing current, forefinger points the direction of the magnetic field, then thumb will point the direction of motion of the conductor or acting force. On the basis of this rule, we have able to find the nature of the force acting between two parallel infinite current carrying wire when either currents are flowing in same direction or opposite direction. Okay. Now in next class I will explain you next topic, that is cyclotron moving coil galvanometer. Till thank you. Take care of your health properly. Okay.